Yeah, oh, I thought you were already live.
Oh, no, 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 I have been doing all other kinds of shit. Oh, shit, I was too fast. Oh, okay, good, good, good. Teams. Things are running up. I was. Shit, I should have done a special thing. Whatever, I don't care. I'm cool. Mute that.
No,
I don't
he's
know why
cool.
this should by default be muted. Can I do that? No, I can't. I don't know. Probably I can, but I don't care. I'm a cool guy. Anyways, um, let's open up that, and in here we'll open up a terminal. And what I wanted to do first of all is that we actually need to take the chat from here. Bruh. Yo, Cutcraft. Let's see. Uh, 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 uh. I have been busy today, which I don't know. I felt like 4 hours of today have gone to. I don't know where they have been gone because I was like, I don't know. I haven't read today. I was supposed to read every day, but today I haven't read, and I'm not gonna because I don't have time. Or I mean, I could prioritize it, but no, I'm gonna do this now. All right. Yeah. Okay. Just gonna swap these two around and live chat. Perfect. So what I want to do first is actually go into .config, and I want to do hyperland neovim. That's not how you spell it. What is it called? That I knew that. And then in here I want to go to bind, and then we're gonna go to here. Should have it here. Oh wow, we cannot do that. Boom. And now, next time I start Discord, it should work with control the meta D. All right, great.
Meta D.
Codcrust says he's my biggest fan. Please give me money. I need money. I don't even have money. What makes you think that I can afford giving money to you when I don't even have money? Did I change the title? Anyways, sick to make VR. Sick to make VR. Yeah, I don't know. We are gonna go in here and we are going to take this one and take it out from there, and then we're gonna move it over to there, and then we're gonna go to the Vulkan tutorial, and we're gonna go in here. And I wonder, is there something else? Finding a job speedrun. No. I'm gonna go to vertex buffer here. Yes. Requires buffer create info. I think we already did this thing. No. No, we did not. No, yes, we did this one. This one we did. We did it all the way through the end. Staging buffer. Yes, this we didn't do. The vertex buffer we have right now works correctly, but the memory type that allows us to access it from the CPU may not be the most optimal memory type for the graphics card itself to read from. The most optimal memory has the VK property device local bit flag and is usually not accessible by the CPU on dedicated graphics card. In this chapter we are going to create two vertex buffers, one staging buffer in the CPU accessible memory to upload the data from the vertex array to and the final vertex buffer in the device local memory. We'll then use the buffer copy command to move the data from the staging buffer to an actual vertex buffer. Ah, okay, this I remember. The vertex buffer may have right now works. Wait, what? Why did it jump? I was like, huh? Yeah, transfer queue. The buffer copy command requires a queue family that supports transfer operations, which is indicated using VKQ transfer bit. The good news is that any queue family with VKQ graphics bit or VK compute bit cables already implicitly support transfer bit operation. The implementation is not required to explicitly list it in queue flags in those cases. Okay. If you like a challenge, then you could still try to use different queue family specification for transfer operation. It will require you to make the following modification to your program. I'm not gonna do it though, but I still would like to read like queue family and find queue family. to explicitly look for Q family with the VK transfer bit, but not the VK graphics bit. That's still quite interesting. Like, you could just do that. I wonder if it's more efficient than having a... Probably not. But you would save like space for the GPU to not have this. Maybe it is more efficient because it doesn't have to do any other checks. Modify the create logical device to request a handle to the transfer queue. Create second command pool for command buffer that are submitted on the transfer queue family. You need a separate... Oh my god. Change the sharing mode of resources to be VK sharing mode concurrent and specify both the graphics and transfer queue families. Submit any transfer commands like VK command buffer, which we'll be using in this chapter, into the transfer queue instead of the graphics queue. It's a bit of work, but it will teach you a lot about how resources are shared between queue families. Abstracting buffer creation. Because we are going to create multiple buffers in this chapter, it's a good idea to move buffer creation to help function. Create new function and move the code in the create. I think I have a create buffer. But one thing I'm already... Okay, I'm gonna read a little bit ahead. So... Yeah, I'm gonna do that, but I want to read here, like, what do they do with this information? Because I was thinking, like, why have separate... that doesn't make sense to me to have separate for the vertex buffer. Why not just use the same? Let's see. So we will take it a bit like this. And then let's see. This here. No, not here. Here. This is what I want. So in the, where am I actually? CD projects Wallenstein and git branch. I'm on the XR refactor. Good. I should get rid of those old ones. Because the thing I need to do is the... How can I not find to do? I swear to God, is it cap? Here, no, not this one. Yeah, here it is. What are the other to dos? Yeah, that's move out to move out. Yeah, okay. Set index buffer. So what is this guy doing here? It has a create translation rotation scale. It takes the camera model, pose position. Okay, that's just what I do. Multiply the projection view, view camera model. Okay. Camera constants. What color? Offset camera. Size of camera constant render cuboids index. And then set pipeline. Buffer data. And then the buffer data here. Set size of camera constant. Whatever. And then set descriptor here. This thing, set descriptor, is what I'm trying to figure out. What the hell is that? From there, thing. set descriptors. Set descriptor here. So they had a VK right. Yeah. And they assume they store it somewhere in this class because this doesn't return anything. Where's the modifier? Okay, the modifier is that. No, it doesn't. Then what the heck is all of this? It just creates this information and it doesn't do anything with it? Oh, that's stupid. Maybe I need to read more about this. We're going to create multiple buffers in this chapter. It's good to do move the buffer creation to helper functions, create new function, create buffer, and move the code, create buffer. Except mapping to it. Why wouldn't you do the mapping? I do the mapping in there. Make sure to add parameters for the buffer size, memory properties, and usage so that we can use this function to create many different types of buffer. The last two parameters are output variables to write the handles to. Terve! How are you doing, Dogaman? Well, I guess that could also work. You could just actually take by reference in them and then manipulate the values rather than doing a return struct that I do. But make sure to you can now remove the buffer creation and memory allocation code from the create buffer and just call create buffer instead. Run your program to make sure that the vertex buffer works properly using staging buffer. We are now going to change create buffer only to use host visible buffer as temporary buffer and use device local vertex buffer. Use host visible. Yeah, okay, wait. So they create a staging buffer and they create another buffer. Wait, buffer size. Okay, and then they have this for memory. Bruh, don't jump. What the fuck? Now using a new staging buffer with the staging buffer method for mapping and copying the vertex data. In this chapter we're going to use two new buffer flags. New usage flags. Buffer usage flags. Okay. Transfer bit can be used as source in memory transfer operations. Transfers can be used in destination in the memory transfer operation. The vertex buffer is now allocated from a memory type that is device local, which generally means that we are not able to use VK map memory. However, we can copy the data from the staging buffer to the vertex buffer. We have to indicate that we intend to do that by specifying the transfer source flag for the staging buffer and the transfer destination flag for the vertex buffer along with the vertex buffer usage flash flag. We're now going to write a function to copy content from one buffer to another. I'd get window. What did you get? Window? No, triangle. Damn. VK buffer source, VK destination, and then the VK device size. Big day in Poland, eh? What's happening? Memory transfer operations are executed using command buffers, just like drawing commands. Therefore, we must first allocate temporary memory command buffer. You may wish to create a separate command pool for these kinds of short-lived buffers, because implementation may be available to apply memory allocation optimization. You should use VK command pool create transient bit flag during command pool generation. In this case, copy command buffer allocation Command buffer. Wait, did it say command pool? We need to start recording the command buffer. Warsaw uprising did 80 years did started. What did 80 years did started? What do you mean? Ah, okay. Crazy. Okay. Oh, wait, where's this? Oh, so they created a separate command pool somewhere else. And immediately start recording command buffer. We're only going to use command buffer once we wait with returning from the function until the copy operation has finished executing. This is going to drive about our intent using buffer usage time submit. We're going to be back after it. Alright, see ya. Or if you're going now, I don't know. Content of buffer transfer using vk copy buffer. Copy. It takes source and destination buffer as argument and array of regions to copy. The regions are defined in vk buffer copy struct and consist of a source buffer's offset, destination buffer offset, and size. It's not possible to specify a whole size here, unlike vk map memory command. Okay. This command buffer only contains the copy command, so we can stop recording after that. Now execute the command buffer to complete the transfer. So you have this, and then vk q submit, q, and then vk wait idle. Unlike the draw command, there are no events we need to wait on this time. We just want to execute the transfer on the buffer immediately. There are again two possible ways to wait on this triangle to complete. We could use fence and wait with vk fence, or simply wait for the transfer queue to become idle with q. Well, a fence would allow you to schedule multiple transfers simultaneously and wait for all of them complete instead of executing one at a time. That may give the driver more opportunity to optimize. But yeah, I'm not doing this yet, I'm just reading. Free command buffer, don't forget to clean up. We can now call copy command buffer from create vertex. After copying the data from the staging buffer to the device buffer, we should clean it up. Run your program and verify that you're seeing a familiar triangle again. The improvement may not be visible right now, but its vertex data is now being loaded from a high performance memory. This will matter when you're going to start rendering more complex geometry. It should be noted that in a real-world application, you are not supposed to actually call for every individual buffer. The maximum number of simultaneous memory allocation is limited by the max count physical device limit, which may be as low as 4096 even on high hardware like NVIDIA GTX 1080. The right now to allocate memory for a large number of objects at the same time is to create a custom allocator that splits up a single allocation among many different objects by using the offset parameter that we're seeing in the many functions. You can either implement such allocator yourself or use the Vulkan memory allocator library provided by the GPU Open Initiative. However, for this story, it's okay to use separate allocator for every resource, because we won't come close to hitting any of these limits. The maximum number of simultaneous memory allocation is limited by the count. Index buffer. In 3D images you will be rendering in a real-world application will often share vertices between multiple triangles. This always happens when with something like a rectangle. Vertex buffer, vertex index buffer. Drawing a rectangle takes two tries. We
Oh, bless you.
Oh, what? I didn't sneeze, I just gasped. With 6 vertices. The problem is that the data of 2 vertices needs to be duplicated, resulting in 50% redundancy. It only gets worse with some complex meshes where vertices are reused in a average number of three triangles. The solution to this problem is to use index buffers. I wonder right now, did I actually mess this up over here?
Probably.
No, I did not.
Oh.
Actually, I did.
Yeah. Wait, what?
Did I actually? Wait. Top, back, right is the same as saying no, top, back, right, top, back, left. Why are these two this? Oh no, they have the minus there. I was like, what the fuck? This doesn't make any sense. No, they are because these are, let's say if I take bottom, front, right, that could be the same as no, because I only have top. So they can never be same because this is already just top and bottom. Yeah, okay, now. Okay, good. Carbon, what's up? I'm going back to after. Wait, what happened? Okay, good. I didn't miss anything. An index buffer is essentially an array of pointers into the vertex buffer. It allows you to reorder the vertex data and reuse existing data for multiple vertices. The illustration above demonstrates what an index buffer would look like for the rectangle if we have vertex buffer containing each of 4 unique vertices. The first 3 indices define the upper right rectangle, and the 3 last indices the vertices for the bottom left triangle. Index buffer creation, yeah, no, this don't need to. It is possible to use either U or U for your index buffer depending on your number of entries in the vertices. We can stick to use for now because using less than, just like the vertex data indices need to be uploaded to a VK buffer for GPU. Yes. Create buffer function that we'll add now is almost identical to the create. There are only 2 notable differences. The buffer size is now equal to the number of indices times the size of the index type. Either the usage of the index buffer would be VK usage index, yes, instead of vertex, which makes sense. That the process is exactly the same. You can create staging buffer to copy the contents of indices. Actually, I just got the banger idea. Vulkan station layers. I'm not a robot, bruh. Why would you assume that? How dare you assume my existence? I don't know. Bruh. I just want to see, can I...
Huh.
I don't have... Fuck. Okay, I will just write it a note. A post-it note, I think is good. Vulkan validation layers. Yeah, you can see that. Supposed to read. Boom. I misspelled everything. Perfect. Okay. Copy indices to, and then copy it. Wait. Since other than that process is exactly the same, you create staging buffer to copy the content of indices to, and then copy the final device in local index buffer. The index buffer should be cleaned up. Using the index buffer for drawing involves two changes. Record command buffer. We first need to bind the index buffer just like we did for the vertex buffer. The difference is that you can only have a single index buffer. It's unfortunately not possible to use different indices for each vertex. Wait, sorry. First need to bind the index buffer. You just like before. Buffer. The difference is that you can only have a single index buffer. It is unfortunately not possible to use different indices for each vertex attribute. So still have to completely duplicate vertex data even if you just one attribute vertices. Wait, what? What am I not understanding this text? Using index buffer for trying involves two changes. Record command buffer. First, we need to bind the index buffer just like we did for the vertex buffer, okay? The difference that you can only have a single index buffer. It's unfortunately not possible to use different indices for each vertex attribute. So we do still have to completely duplicate vertex data even if you just one attribute vertices. What? Like they're saying that you can't have duplicate, but then we have to duplicate. What? Okay. What the fuck? Okay, I'm just gonna. Yeah. It's okay. Yeah, it's okay. I'm confused too. Yeah. So I'm gonna have to do this kind of call now. See that image dot command buffer first binding count, and then vertex buffer. This is just called cube vertices dot. No, just. Is it that? Is this okay? I think it's okay. And then offset will be 0. Where do they do this actually? Bind index buffer. I think this is the right spot to do it. And then image dot command buffer indices, cube indices, offset 0. I don't think we have 16 for them. What do we use? We have U32. I guess 16 is fine. But then it will complain everywhere else, so I will just keep it to U32. And that is fine. So we'll just type U32. And an index buffer is bound with which has the index buffer a byte offset into it and a type of index data as a parameter. As mentioned before, the possible types are VK U16, yes. Just binding an index buffer doesn't change anything yet. We also need to change the drawing command to tell Vulkan to use the draw buffer. Remove the VK draw line and replace it with draw index. I just have a VK draw. See vk command draw index, and then the same idea, image dot command buffer. Oh my god, I'm just gonna do that address like that. Okay, wow. And then static cast indices size. Well, I can just do indices cube indices dot len. I hope with the cast I don't have to do it, but I don't know. And what are all of these other parameters? We have command buffer, index count, instance count. I'll just put 0. Ilio, you are a warrior, brother. You keep pushing through the hard parts. Keep doing what you do. Thank you. Thank you. I will keep pushing. I will keep pushing. That's what I do. Feel kind of silly because I'm like, I have to reread the Vulkan tutorial to remember what the fuck am I supposed to do. A call to this function is very similar to vk draw. Okay, the first two parameters, yeah, you can see here. But I wonder, like, please don't push pull doors. Yeah, I won't push pull doors. I do occasionally, but it happens. It's not much I can do about it, you know, because they don't put a sign. What am I supposed to do? So I try pushing and then pulling, and then neither of those work. Please don't push doors. Do I have a? I don't know. Okay. A call to this function is very similar to vk draw. The first two parameters specify the number of indices and the number of instances. I think that's incorrect. The first one is the command buffer, but sure. Maybe, well, that's maybe what they mean still. We're not using instance, so it just specifies one instance. Oh, yeah, that's true. The number of indices represent the number of vertices that will be passed to the vertex shader. The next parameter specifies an offset into the index buffer. Using a value of 1 will cause the graphics card to start reading at the second index. The second to last parameter specifies an offset to add to the indices in the index buffer. The final parameter specifies an offset for instance which are not you're not using. Hold on. I'm still missing a few parameters. Okay. Well, now you know how to save memory by using vertices with index buffer. This will become especially important in the future chapters. We're going to load complex 3D models. Mentioned that you should allocate multiple reads like buffers from a single memory allocation, but in fact you should also go a step further. Driver developers recommended that you also store multiple buffer like a vertex and index buffer into a single VK buffer. Multiple like the vertex. Okay. In command like VK bind vertex buffer, the advantage that your data is more cache friendly in that case because it's closer together. It is even possible to reuse the same chunk of memory for multiple resources if they are not used during the same render operations. Their data is refreshed. Of course, this is known as aliasing, and some Vulkan functions have explicit flags to specify that you want to do this. But yeah, I did not do the copy thing because I'm not really concerned about that yet. This is what I wanted to finally read about, because this is what has been... I'm reading the OpenXR tutorial, I'm like, what? How did the descriptor layout sets work again? I'm like, oh my god, I don't remember. Descriptor layout and buffers. We're now able to pass arbitrary arbitrary attributes to the vertex shader for each vertex. But what about global variables? We're going to move on to 3D graphics from this chapter on, and that requires model view projection matrix. We could include it as a vertex data, but that's a waste of memory and it would require us to update the vertex buffer whenever the transformation changes. The transformation could easily change every single frame. The right way to tackle this in Vulkan is to use resource descriptors. Yes, a descriptor is a way for shader to freely access resources like buffers and images. We are going to set up a buffer that contains the transformation matrices and have the vertex shader access them through a descriptor usage of the descriptor consists of 3 parts. Specify the descriptor layout during the pipeline creation. Allocate the descriptor set from a descriptor pool. Bind the descriptor set during the rendering. So during the rendering, okay. I'm still a bit confused, like when everything is supposed to like interact with each other, but I think by just doing this more and more, every time I do this Vulkan setup and the graphics pipeline, I feel like I'm getting a little bit stronger understanding of how everything is connected, but it's still like, fuck. Okay, the descriptor layout specifies that the types of resources that are going to be accessed by the pipeline. This is the types of resources that are going to be accessed by the pipeline. Okay, just like a render path specifies the type of attachment that will be accessed. Okay, now, okay, that I understand what it's saying. A set specifies the actual buffer or image resources that will be bound to that descriptor. Just like a frame buffer specifies the actual image views to, wait, what? Yeah. Just like a frame buffer specifies the actual image views to bind to render path attachments. The descriptor set is then bound for the drawing command. Just like the vertex buffer and the frame buffer. Set is then bound for the drawing command, just like the... Okay. There are many types of descriptors, but in this chapter we'll work with the uniform buffer object, UBO. Bruh. I'm reading backwards. We'll look at other types of descriptors in the future chapter, but the basic process is the same. Let's say we have the data we want the vertex shader to have a C-struct like this. So then you get the model view projection, MVP. Then we can copy data to VK buffer and access the through union buffer object descriptor from the vertex. Okay, wait, so do I need to even do this? Because if it's just for... Oh, I might not even have to do this. Ooh, okay. Okay, because now this is kind of clicking for me that... If it's just for this case, I already have... Oh, yeah, I don't have to. Yeah, but it's only for like shared memory that needs to be used for like the model view projection matrices. Every vertex needs access to that. And if I had images, well, textures, I could also pass that. Or if I had a... I also did this, I remember, for Skybox and UI. But yeah, this is not... Now I don't need... Yeah, I don't need to do this right now. But I still want to continue reading, but I think I can now go back to this. If I'm not mistaken. I think this is just for the model view, and that I already have a descriptor set up from this tutorial. Or actually another tutorial, but the same thing, it's just in a different place. You have to render first your skybox and then your space. Yeah. But I don't have it for here, it's another project where I did a skybox. So, yeah. Actually, it's... I don't know, it's... can show... I have it's here. I think I did it in this one, train generation. There I added a skybox for the whole thing. So it was pain. Still not quite sure how I did it, but it worked in the end. So that was nice. But Then this should be set up, and then I don't know why it sets to. It sets for the camera and then the normals. Huh. Ah, yeah, but if I don't take in the normals, I can ignore this. That looks cool. Thank you, thank you. I actually think I might get back to the project and just completely redo it. It would be nice because I think I'm actually learning more. And I don't like how I have set up the whole project. It's just ugly. Ugly. Ooh, ugly. But yeah, let's see. This should be begin render pass. Draw. Yeah, here, bind this, and then it's basically the same. From the past in pose, the scale we create. Let's see, because yeah, this is okay. Now I understand. This is I don't need to worry about this. The only thing I need to worry about is this, which they have their own kind of API C++ class for. But I will do it in my own way and hope for the best. From the fast in pose and scale, we create the model matrix, multiply that with the constant to obtain camera constant model view. The matrix. Oh, you could actually just. Oh my god, wait. If I go to the vertex, right? Bruh. Could I just, by default, multiply the matrices together so I don't have to do it within the shader, and then just pass the already multiplied value and just multiply that with the actual. No, wait, that's the view index. Yeah, here, and then take just the vertex and multiply that with the already multiplied. Am I mistaken? Could I not just do that so I don't have to do it within the shader? And then I just would have to do it once on the CPU. Right? Or am I stupid?
All of the above?
I'm not good with matrices, so I just know you have to do them in a specific order. You pass it from the CPU to the GPU. Yeah. But it's yeah. But I wonder, like, because what I'm doing right now, I'm passing the projection, the view, and the model over to the shader, and then I do the multiplication here, and then I multiply with the vertex position. But I wonder if I could just switch this around, or like do this matrices, the calculations of them on the CPU, so I don't have to do it for every single shade, like every single vertex. That's just a unnecessary step, right? This should work, right? Because they're all on the left side, and then you multiply it at the end. Suppose you can do it from shader also to GPU. Yeah. I mean CPU. Yeah. I don't know what. Yeah. But let's see. I think I will try it after I have gotten a cube on the screen. I can try that out, because that would be. I just want to see, like, if I understand it correctly. You should try it and think it should work. I know you can go both ways in Vulkan, yeah. But let's first get that cube on the screen, and then we can see. From the past in pose and scale, we create them, multiply that with the to obtain model view projection. The matrix that transforms the vertices in our unit cube from model space into projection space. We apply our pipeline, which contains the shader and the render state. We update two uniform buffers, one containing the camera constants for the vertex shader and another containing the normals for the cuboid. We assign our vertex an index buffer and draw 36 indices. I will not pass in the normals, because then I would have to create another descriptor. So I will just not do that. Also, the normals could if they are actually, wait, am I actually this stupid? Oh wait, but do he multiply and it? I don't think he does anything with the normals. He doesn't. Well, isn't this completely redundant then? Like, why pass in normals like this? You could literally just keep them in the shader instead. Well, I mean, if you wanted to change all of the normals for... Oh, yeah, I can see in the case of changing the directions of the normals or something like that. I don't know. Then I see that you might want to pass them. But otherwise, they could just be loaded in the shader and just statically there. This is kind of like redundant. Maybe. I shouldn't judge too quickly though. But for me, that doesn't sound like a smart way to do it right now. Right now, okay. And I'm no expert also, so maybe I should maybe just read further. Now moving to the render layers method under the call to clear depth and before called render. Okay, so API sets render attachment swap chain images view swap chain image view depth width set scissors projection to view multiply. The section sets the color and the depth image view as rendering attachments to for out merge color blend stage to right to. We also set the viewport for the rasterizing to transform from normalized device coordinates to texel space, and we set the scissors for the rasterize to the cut. I'm actually concerned that I'm not doing the pose correctly. We'll see once I get a cube, because then it will be a lot more easier to have a point of reference. Our viewport and scissors covers the whole render area. Next we compute projection and view matrices, and we multiply them together to create a view projection matrix for camera constants. Now add the following code. And then they call render cuboid. What the hell? Okay, so this is for each cuboid. Okay, then it makes sense. But I'm just gonna do one of them. But here they do a bit of a... What are these parameters that are passing in? They are taking in... Wait, there's just... scale. And the scale is here. And then they change everything there. Okay, I see. That's why you pass in that and then... Okay, I see. It's okay, I will just leave it for this. First set render cuboid index to 0 and call the render call twice to draw cuboid. So the first is offset by arbitrary view height to represent the floor. Scale it by 2 meters in the horizontal. And that's the last parameter here. Direction 1 in the vertical, so it's flat. With that, we should now have a clear color and 2 cuboids rendered to each of the your XR system. Well, it's probably not gonna even compile because that's just how I do it stuff. You know, I don't like it to compile. So let's see how far we can take this. Okay, we're gonna take some time. Hello, Chupak. First problem. I'm actually gonna do dash watch. Okay, so does not support array initialization. Well, shit. Oh no. This is not fun. Sig main 31. That means all of these don't appreciate me doing it like this. I think there's a... We can probably do like this. So we can say dot x And then, oh shit. Oh no. Oh no. Okay, let me just do this again. How did you not? Oh, because you didn't. Okay, I think if I do, there is no easy way of doing this, is there? No. But I can do this, and it will work. Yes. Okay, X, Y, and then we'll go. Oh yeah, fuck! I forgot. I need to say dot, like so. And then we'll go here and save. Shit, I might not be able to do it here, but we can do for most of them. Like so. Set is equal dot set that, and then we'll take the last one. Dot set. That's not a set, and that's not a dot. Where's my dot? I should have done from right to left. I switched to openness use USE, and there is no more mouse delay in Hyperland. Amazing! What is openness USE? I haven't heard of that before. And then dot W, like so. Okay. And now same for these ones. Yay. It's okay. Dot X is that. Can I please? No, it doesn't work. Okay. Fuck. Dot Y is not. Is this? And then dot set is this. These two have to be a bit different. Dot set is this. And then we'll have this one, which is dot W, dot W, dot W, and dot W, like so. And same for these ones, I assume. Cube in this. No, wait, these are just U32s. Nice, 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 nice. OpenSUSE is an operating system. Very nice, actually. Ah, okay. Wait. Open SUSE, like. Can I play it like this? It's a free and open source Linux distributed developed by the OpenSUSE project. It's offered in two main variations: rolling Linux distributed and leave. Okay. Crazy. Okay, pretty cool. So let's see. Now it has expected void pointer found. Const. I could do a PTR cast. Yeah, I think a PTR cast is best case scenario here. I'm not sure. 140 here at PTR cast. So, and let's see now. Discard const qualifier. Oh yeah, they should not even be const. Or maybe they could actually be const, but now they can't. Oh wait, but they are. Well, we will see how this goes. I don't know, and I think they might have to be const there. Let me just rerun this accidentally. Vulkan 458 expected struct found comp time. Fuck. 458. 400, 458. Here. Bruh. Should I just call it undefined in that case? Oh. Okay, but it's just a pointer, so it will be assigned after. So it's okay. Value type C int ignored. Okay, create buffer. Yeah, it returns. Okay, so we'll actually do a try loader vk check. And then, yeah, same for this one. Memory requirements undefined. And I'm gonna assume the same for this one. And no field name memory type bits instructs to properties memory type bits. Let me check that. .471 here. Memory type. I think it should be that, right? We'll see. Maybe it will run, maybe it won't run. Who knows? Incompatible types 32 struct type and U32. Right. Wait, how does this work now? Let me think. Let's see. Because I'm not really sure what am I trying to access right now. Let's see. So what are you passing into here? They are taking type filter, but what do they pass there? They pass in mem requirement type bits. Okay, maybe I have that wrong. VK memory requirements, right? Ah. What the hell am I doing? Why do I... Okay, I need to reread this. What the fuck? Why did I write it like this? Wait, why shouldn't it be like... Let me check. We have another one. This is also in here, actually. No, it's in here. No, it's not that one. It's in here. And we're gonna have a shift. What? Then it's not in here. Is it in here? No. I call it shifty. Why doesn't it find shit? Oh my god. Okay, here. Shifty, here. Oh, this one is actually... I have actually done it wrong. Requirements. Oh no. Okay. Okay, what is the next one? Expected type found, and that's 448. 484. Bruh, what am I saying? I'm always saying something that doesn't make sense. Expected null type of null. Okay, how do we do this in here? But I can't tell for sure that it's going to be what I do right now. Can I just pass undefined? Is that okay? Any opaque. So then I can do at pointer cast. And probably alignment cast, no? Okay, I actually thought there would have to be an alignment cast as well, but apparently not. Expected type void pointer found U30. Shit, actually. Ooh. Main 148. That's a bit hard. I don't know the best way to do these things when it comes passing sig like types to C. I usually solve it with pointer cast, which maybe is good, maybe it's bad. If it works, it works. Oh look,
Until it doesn't.
Till it doesn't, exactly. Damon, my man, gets it until he doesn't. The funny thing is that we are not even using the normals right now. They're like completely redundant. I should probably just remove it and never call anything to do with normals. I should, but I'm not gonna. I'm gonna get these cubes running first, and then I'm gonna do what I'm telling that I'm gonna do. Expected Vulkan buffer found. Okay, so try, yeah. 175. Was it main? It was main. 175 here. Wait, what? That doesn't make sense. 175. Oh, okay. So because I do it up here, these ones also needs a try. I can probably do like this. Easy peasy. Try. And then expected type bool found void. Damn it. Okay, so if 490 Vulkan. So if is not equal to null and data is not equal to null, then we do that. Okay. What? You cannot do that? With null. What? Comparison of... You cannot do this? No fucking way. Do I have to... Okay, I need some advice here. What the fuck? Mismatch of... In sig, null is not universal value that can be compared with any pointer type. Instead, null is a sentinel value used with optional pointers, and an optional point... Oh, I need to make them to an optional pointer. And then I can do that. Okay. I'm gonna make them optional pointers. Fuck, but then I have to... No, this should already... Fuck, I might have to do some other shit if I do that. Then I have to do the... You know what? We will not do this. We already do the check that it works, so... I'm just gonna do this. Unable to resolve comp time value, so... Well, fuck. Shit bands. Why? Because I need to take from... Well, I actually need the whole memory, and no, I actually need this. Could I just take... I don't think I can do that, like, can't I? It's a comment out. This is safe feature prevented from common scene errors where you slice a pointer with a wrong or unknown size. To ensure that the slice creation change the map and data to slices. Instead of passing raw pointers, you should pass slices to a memcopy slices pointer and a length. The data variable is like already a slice utility or similar, but the thing is that I don't know what that will be. Use, and then it's inventing new methods, amazing, or new macros. Function calls, this doesn't exist. So what I will do instead...
You're not streaming in Discord.
Oh shit. Let me change that real quick. Let me change that. Boom. Now I'm streaming in Discord.
Nice.
I will just I think I will just remove it, and I think that's fine, right? That's legal. I think that's okay. But the mem copy that I do in other places is kind of like they're static, because I know that they will be a specific length. Now I don't know what their length will be, so I cannot make the same, like, I cannot write statically, use this size and this size, it won't work. Because in here, I can just say, wait, but pointer is 0. But I then tell that plus 16. And then I have plus 16 here, so I guess it will know. But I cannot say for sure. And then I'll just say here unknown, but if this was a random unknown, then I think this wouldn't work either. But shit bands. That's what I like to say, you know, when things are weird and not working. Actually, one thing I need to change still, like, this one is fine, but I think this... No, wait, this one was not fine. This one is fine, because this one still has the old, but this one I think I accidentally... No? Want expensive viewers? Go to Vulkan. Remove spaces. I want expensive viewers. Vulkan.org. Where do I get my expensive viewers? Develop from scratch is telling me I can get expensive viewers. You developed from scratch is really nice. He does cool shit like wait, where? He doesn't need a shout out, he's even better than me, but you know, we here. It's he does cool videos. This one is probably the coolest still. I need to continue watching this one, because I'm curious to know about the Raspberry Pi. I need to find something to do. I keep wanting to raid one of your streams, but we are never streaming at the same time. Yeah. It's it happens. Do we have... But yeah, we should probably like put our links to streams as well, so we could so we could easily find each other's streams if somebody just wants to raid. Do we have Andrew online, or somebody who is a SIG nerd? Andrew is online. Let's see. I'm gonna try to get Andrew in here. And I pressed the wrong buttons again. Let's see if I can get him in here. Or maybe Cheesecake. Maybe Cheesecake would like to come and help. I'm gonna ask Cheesecake as well. Cheesecake. Or Xorbit? Maybe Xorbit can help. Let's see. Who of them will show up to help me figure this shit out? None of them? Damn, well, I guess we'll have to figure this out on our own. One other option I could do, I'm just gonna say it for later, for when, if one of them arrives, you know? Just to go forward, I think this will be okay. No, its type void is not an indexable point. My ass, no. How can I mem copy then? I need to mem copy. I want to mem copy. It wants slices, but I cannot work with slices because I don't know exactly what data type I will be working. Well, I guess if you do dash a asterisk t. That when you create a slice from a simple pointer or void using start and syntax requires an end value, in your case buffer compile time constant. The compiler is telling your... Why can you just not copy byte by byte and I could just tell you how many bytes, because that I got that information. It doesn't have that information that it's trying to tell me that I have. It doesn't have a third parameter, it only has... Be nice if memcopy had a size meter. Is, for example, like a size. However, in SIG approach, memcopy is intentionally different, and it's a great example of SIG's design philosophy of compile time safety and leveraging the time system. You correct, the documentation provided allows 2 parameter version, but here there are actually 2 ways to use memcopy in SIG, and one use depends on whether the size is known at compile time or at runtime. Yes. Runtime memcopy. Does it actually have... No fucking way. SIG memcopy. Copy? Slice of bread. Yes. Memcopy. I don't think it has... I have never seen memcopy with a... What if I want to do it during runtime? Runtime. There isn't much here talking about it. And Gemini is giving me bullshit. Because there's no way I can do this, right? There's no way. I cannot put in the memcopy size. That's no. Okay, let's see. If I put, let's say 32, right? Yeah. Found 3. It won't even allow me. Like, no. No, it's not possible. So how do I get with the pointers? I know the size and I have the pointers. It won't work. it only takes 2 params. Now, with 2 void PTRs, how can I copy the memory over memory? I don't know. Fuck this cable. Jesus Christ. I need to get something that can hold the cable so it doesn't get in the way. I don't know the data type will be. I do know its length in bytes. Well, I guess I could know by always passing in, but I could do. You're right, and apologies for confusion. The SIG documentation and built-in function is a bit subtle. SIG language, the memcopy function is not built-in. Wait, what? Oh my god. Cast the void pointer to a U8 pointer. The U8 type represents a single byte. Casting to U8 allows you to treat the memory as a continuous block of bytes, which is what you need for raw memory copy. Correct the slides from the U8 pointers and the length. This is done using on the cast pointer, use std memcopy to perform the copy. That sounds like a disgusting way of doing it, but maybe that's the way I have to do it. Or I could always take it in as a U8. I call you cheesecake because how should I do this in a SIG kind of way? I need to memcopy, and I got 2 void pointers. So this function returns for a GPU accessible memory address, a void pointer, and then I pass into the function a wait, oh my god, yeah, here, no wait, what, where am I? Crate buffer, yeah, there. I pass in the data I want, because this can be different. It's not it's not always a it's different stuff. Just a continuous block. Yes, you did just see void in C. Well, at least it compiles. I don't know, man. Any opaque. Anyways, okay, I will change it to any opaque just for you. But how do I still memcopy this? Because I know the size that I want to memcopy. All right. That is stored here in buffers crate info, and then just size. I have that. Here you can see it. This is the amount of bytes I want to copy, but I don't know how I can do that memcopy. I just asked Gemini and they told me I should typecast to a U8. Like a source byte U8 pointer cast. And then this. And then I could do a slice. And then I could do the memcopy. You know, I just want to memcopy memory. I want this memory to be copied over to this address. If this was C, I would like to do memcopy destination map data, and then from source data, and then I would like to do it for this amount of bytes, right? This is what I would like to do if it was C, but I can't do this in SIG. Maybe I can also show you the error message. So, am I still running? Oh, this is yeah, it's so here, unable to resolve comp time value. So it's like, because this will be different depending on what I pass in as well, the size. Like ChatGPT is telling me that I should take this and then make it to this and then do the memcopy like this. So I would cast the void pointers into U8 pointers, which is characters, right? And then take the slice of those and pass the slices in here. Is this the way I have to do it? It's a bit weird, you know? Maybe it could work, but I wonder, is there like a better way? I will just do this. So before we go here, we do that. Then I do this. And there's no such thing as this. We just have the destination, which will be map data. And then we have the source, which is this. And yeah, I don't think I need to do that. I can just do this literally. And we take this away as well. And now we should have that. And then this, and then here we will just pass in. But then I have to, yeah, I don't have to do anything else. That's fine. Yeah, this should be fine. So destination, slice, and source slice. Let's see. Oh, amazing. It does not support array list. Perfect. Do I just call them buffer? Bruh, I didn't even. It's equal to this, and then memory is equal to that. Shit, what did I do? I pressed the wrong button. That's what I did. That should be fine. Unless I put a comma somewhere. No, that should be. Okay, for fuck's sake. What do I call the struct? It is buffer. No. Expected. Like so. Okay, now this was. Oh my god. Okay. Expected bool found U38. Shit pants. Or. Right, here I have the parentheses incorrect. I knew I had something wrong there. So either we do this one. I want like that. Oops, not like this. Like this. Either it's this one or it is that one. Yes. Expected type found vertices struct command buffer. I guess the pointer cast is fine. Can I jump to this? No. 309 in main. Okay, I'm basically there. No, 903. Why am I reading numbers backwards so many times today? Oh my god. Okay. 902, I mean, also, like, what the fuck? At PTR cast, and we can remove this, and we can put this here. Alright, let's see. Bind vertex. Increased pointer Has alignment 4. Wait, has. So this one has an alignment of 4. Construct buffer has alignment of 8. Use alignment cast to assert. Does it actually take alignment of 8? Cube vertices. Well, it's not really clear what alignment it has, but I guess. Okay. That's big alignment, but okay. At align. What the fuck? Alignment cast. Expected bind found. Oh, expected pointer. I need to do a pointer cast and address. Do I also have to do maybe a alignment cast? I don't know. Probably, maybe. Let's see. Okay. Well, how far did we go? Initialization failed. Perfect. We're getting somewhere. I'm gonna plug in my headset now.
No, oh my god, my cable management is so bad. Boom. Unless they go over there.
And because I have base stations, I also need to plug them in. Alright. So now I have plugged in that. Let me close this. Oops, what am I pressing? I'm pressing buttons. And don't need that. We go here. And then git good. Okay, for fuck's sake, I got this. There it is. GitHub. Wallenstein. And we're gonna run with dash null. So, okay. Let's see, what did it say? Event for unknown object not handled. There's a lot of errors, but yeah, it failed to get my controllers. That's fine. Because we don't care about controllers for now. Well, we should care. I will run it watch. Segmentation fault. Well, that's not good. Yeah. That's not good. Oh, thank God, we got to see. You can stop now. Oh no, I closed the whole thing. Shit. Whatever. We can check these things. So it got into the enter while. It got multiple times into the while loop, and then at some point I must have messed something up, right? Ah, no. The first time we actually got into this. Okay, so let's see. That's in the render eye. So it's actually in here. Should be render eye. Render what? Okay, there it is. Okay, so it's an input, but wait, input is. Huh. Okay. So I got the input, and then it probably went into render, and along here somewhere we'll have a segmentation fault because we access a null address. Wiki bind buffer offset is null. Woken specs offset must be a valid pointer to an array of binding count device values. Well, fuck me, there need to be something. I thought you could just pass in 0. Okay, well then we'll have to pass into the bind a valid address. I thought you could just pass in null there.
Our good friend Valid.
Valid. We combine vertex buffer here. Offset, this thing has to be something. Shit! Well, let's see. I don't remember. Offset device. Okay, so they literally just. Oh.
You still need help?
Yeah, he needs help all the time, dog.
Yeah, I'm I actually do. Okay.
You know, you shouldn't be coming in here like all friendly asking. You should be like, "Yo, man, I'm here to take over. Like, take your hands off the wheel, dude."
That's enough driving for you, Lucas, today.
Just be like, I got the gloves on now, man. Let's go.
Okay, this is what I wanted to do, okay? So, I want to copy information over the vertex buffer, right? The vertices over from the CPU or the RAM to the GPU, right? So I have this create buffer, which takes in the data, which is any opaque, because I can also use this buffer in other places. That's why I have it to be this, because I don't know what this data will always be. And then I do all of this shit, and then here I have now gotten a pointer to a memory address that the Vulkan will take care of to get the memory to the GPU, right? So then I need to memcopy. Well, this is actually what I tried to do before. I tried to take. Well, this is how I want to do it in C. Actually, this is not what I tried to do before. I want to take the data pointer and copy it over to the map data for this many bytes. I know the amount of bytes I want to copy over. And what I did was, basically I did this for now. I cast it to an U8, right? The mapped and this. And then I make a slice out of it. I assume Len will know that I'm talking about this one, right? And then memcopy works, I assume. I haven't gotten proof of it yet. But this is how I do it right now. Is this the way to do it, or is there a smarter way that I don't see?
Where you got length?
Length is because I pass in the type size and then the length. So if it's F32, I take size of that and pass it in here, and then I know how many there are in this slice thing that I pass in usually, or some way I will know the length that I will have, and I will know the types that are in this thing before I pass it in.
Yeah, I think it's correct. One thing you can improve, maybe, I'm not sure if it will work.
Yeah.
You can try to make your own opaque type, like not any opaque, but just opaque type.
Wait,
It's
what?
a keyword, just like struct and the enum and the union. It's
Oh,
you
you're
can
making
create
a
opaque
union.
struct. You can create opaque type, and opaque type is just something, and you can only point to it, but it can have methods on it.
Yeah.
You can create like methods to copy it on something.
Actually, one thing, well, I don't. Slices cannot be generic. There has to be a type, right? Or could they be? Could I pass in a generic slice? Because then I could just say len. And nah, because
You can pass type, and later you can pass size of a type.
That could also work.
Yeah.
But let's see if this works first.
It should work.
Yeah. Let's see. So now in here I need to do this thing. I wonder, maybe I should also do this. They cast a vertex buffer into a VK, but isn't it a VK buffer? No, it's not. Wait, I'm also passing the wrong thing in here. I should not pass this. I should. Oh my god, what am I trying to do? This is so wrong. This should actually be self. No. Self dot This is the vertex. What did I call it? I call it vertex buffer.
No way. YouTube just invented collaborative videos.
What?
It now shows you video is uploaded by like Mr. Beast and 3 hour creators instead of just one channel.
What are you talking about? I'm confused. I have something weird in my upload?
Oh, very just interesting. YouTube.
Ah, okay. YouTube is just being weird. Okay, I was thinking I was doing something weird, which would make sense too, but... Vertex buffer, like so. That should be it. Why is use of unclear identifier self? But that should... I am within a place where I should have access to self. Oh wait, no, this is a... Yeah, no, wait, I'm actually calling this... So I don't have access to self. Well, that sucks. Let's see, how can I change this to... Maybe I will do this. I will not even make them members of that. I will just keep them outside. Because that could work for now. Maybe. So we'll just not do that. And I will just say it here like this, because they will not be here forever. They will just be for getting this working. War. And like so. Variables must be initialized and defined. Alright, so, and then we can, instead of doing it over here like this, yes, they will complain, we'll just do that, and that, and then we don't need them in here anymore. We can do this. Actually, we can just remove it. And then if you go back down here, yes, index buffer, and then we can also, but now I could see the index buffer is a Vulkan buffer. They cast it to just a buffer. Well, I do the pointer casting. It's alright. I'm just gonna do this as well as they do it. I'm gonna go const, and then oops, not that. Oh my god, I'm messing up all of my key bindings. Okay. Offsets, like so. And let's restart the Monado. Like so, I'm still live, right? Yeah, I'm still live. Does not support array initialization syntax. Hello world, you're still alive? I don't think so. Nope. It's like this, unable to infer array. So how do I do it over here? I do a horrifying thing like this. Well, I could just say that it is 1 that contains 0. Yeah, expected found. Hello world, Doritos guy. Yay, Doritos guy, welcome. Sirboso. Sirboso. What? Eldon is not here to trying to convert me to a Emacs again, I hope. At PTR cast. Like so. Might have to give it the pointer. Yes. And let's see. No field name, vertex, buffer struct. What? Yeah, I don't need to destroy those anymore. Or I need to, but I just remove self from all of these. Should be fine. So string replace self with space G. That should be fine. Dot logical though. Fuck. Undo. Self dot. Wait, but okay, wait. Actually, this one needs it. What am I doing? String vk underscore. Let's replace that with self dot vk underscore. Hey. Okay, another segmentation fault. Woo! Bighill -9 Wallenstein, like so. So trying Emacs today? No. Duration vk bind invalid buffer object. If buffer is not vk, buffer must be a valid view handle. Maybe because I didn't do the casting. Well, I'll do the pointer cast. I thought it would be enough, but maybe it's not. Maybe I need to do this also. Oops. Another segmentation fault must be Tuesday. What do you mean? What do you mean? And this one should also, I just realized, be var. Otherwise this won't work. C dot this vk, I'm gonna call it 1, and I'm gonna tell it to be this. And we need one of these. And yeah, we don't call it vertex buffer, we just call it underscore vertex buffer. And not use local index buffer might need something similar actually now when I think about it. I might not need alignment cast anymore, let's see. Because we just call vertex underscore buffers, right? And the password buffers. And let's see if I now run this application. So it has not member vk buffer. Well, vk buffer there. The pointer points to nothing, and so do I. Okay, looks like my pointer have a commitment issue. What? If it points to nothing, how does it have a commit? Oh. Okay. Expected this, and it found this. Oh, so I should do the pointer cast here. But then I need the alignment and pointer cast. Sure. Sure. Let's see.
Shut.
Doesn't need two addresses. Local is never mutated. We should pass address. Oh yeah, not pass address. Another seg fault. Whoa! Let's see. Now we have duration time PK1. Invalid object. Valid or well, now that should not be invalid. That should be a valid one because buffer we create an array. Wait, was it indices or was it vertex? It was vertex. This one is definitely valid right now. Because I do create it over here. Create the vertex buffer. It assigns it to this one. What you call buffer usage transfer bit buffer use vertex buffer. Unless something fails inside of here. But then I just return the struct with the buffer and then the memory, which should be all valid. So this is funny. Why would it? Unless I do some casting incorrectly.
Coach?
Couch?
Coach casting?
Yeah. Another another day in the office. Yes. P-buffer must be valid pointer or an array of binding count, valid or null handle buffer handle. But it should be alright, you know what I'm saying? I'm just gonna... It's Gemini time. Actually, I think it might be better to still continue on with this one, because then it has reference to my VK bind. That it might be, yo... The issue is that you're passing an invalid handle to the segment fault. Strongly suggest that the invalid handle is null or a pointer to a garbage data causing... Right, it is actually. I am stupid. How could I be so dumb? Because this thing is not that. This is the thing I need. No, where did you start? No! Ah! But that's still funny that it doesn't work. But there's a bit more now. Wait. Yeah, but it needs to be... You need to take the But then we don't need to do a pointer cast here. We can remove the pointer cast. And we don't need to do this, probably, maybe. Fuck. So now we will take the vertex buffer dot buffer. How could I forget about this simple thing? Like, for real. Yeah, that should be it. I'm not gonna run watch anymore because now I'm getting to precise details. Yeah, it expected struct. Wait, what? It expected C import struct VK buffer found C imp. Oh, it found. Yeah, that makes sense. Why? I thought I removed this thing. Okie dokie. My GPU broke up with me. Said I was being too implicit about my feelings. Should use Vulkan. Yes. Should I use Vulkan? Let's see. So now it's still the index buffer is still could not. Let's see, validation layer agile not available. Well, that should be fine. Unless I do some other fancy shit somewhere else. I don't think I do any other fancy shit. Access the buffer field. The struct. But still. And let's see. I will take a little bit more. Okay, whatever. I'm gonna take a new one. And I'm gonna say just help. It looks at frustrating. It seems Vulkan validation layers are catching issues how trying to bind your index buffer. Yes, that's exactly what's happening. Successfully double check that the code you created create buffer return VK success. I think I better be doing that. Create buffer, yeah, I do have. It's called. Yeah, these getters don't need to be checked because then these ones would fail also down here below. Was destroyed too early? I don't call destroying it. I like how AI is like, yeah, that looks like a frustrating error. Thanks, bro. Yeah, thank Gondar. You're damn right about it. It doesn't really help if it tells me it is, like, fuck. But I'm not destroying it too early, because the only place where it could destroy it is... I'm not even... Yeah, no. I think I'm not even destroying it properly, to be honest. No, wait, I am. I hope. You're passing the wrong buffer handle. Although your code snippet shows you're binding vertex buffer, there are suspicious about... Sorry, what? I just assumed that it was speaking about binding the vertex buffer. But obviously it's not that. I fixed the fucking problem. I was like, it doesn't work. Oh my god. Please, Lucas. Okay. Bind, but does this one just take in a... Yeah, it just takes one, the index. Okay, yeah. This was no longer the problem, this function call. It was the index one that is problematic, and that's because, well, You guessed it, I'm not passing in the buffer, I'm passing in the struct that it doesn't know what the fuck that is. Whew, okay, now. Okay, at least it's not seg faulting, so that's pretty fucking good. Oh, I think I have messed something up, but something is there. Why is it flat though? How can I think I have a lot of things wrong here. Looks good to me. Okay. I mean, it's a step forward at least, you know. We are not having seg faults, so I think that's pretty good. Oh my god. I just wanted a box, but I got the plane and a weird triangle. Oh, I know what's wrong. Oh my god. I know exactly what's wrong. Oh my god. Might be a good base for a psychedelic game. Wait, let me actually just take a beautiful... Can I move? Why does it like trip so much? Like, please, I just want the... Okay, I can't do this with one hand. Shit. If I put it down, please just stay there for a while. Thank you. No, don't move. I want a screenshot of this. Allow and remember. Okay, now I can kill it. And then we can go into here. This is just video documentation, all right. I will take, if it's okay by you, Gunnar. I will take your beautiful. It looks good to me here. I might use it in the video. Perfect. Let's see, what do we have for... Oh, it's a new month already. Holy moly.
Yeah.
Time is flying. But yeah, you know what the issue is? My mat broke. Not really, but kind of. Stupid wheel. Okay. In the vertex shader, I'm still doing stuff I should not be doing. So that's kind of problematic, isn't it now? So what I will do is I will not do this. This is redundant. Am I even taking... What the fuck? How I'm very confused how anything even worked, because I'm not even saying layout location 0 in a vec4 and these are the vertex, these ones, vertices, vertex or vertex, I think it will, how will it be? I will just call it vertex. I'm not sure now, I might be a bit lost. Fuck. Shit. What am I doing? Let's actually just... Okay. So, like this. And then we just say vertex... Do I just say vertex? Do I have to say GLL? No, vertices. It is vertice. How does this work? How am I actually supposed to create... I don't know how to do shaders, bruh. How did I do it before? Okay, so I will get in... I know the issue is the shaders. Welcome back, Pig. But I'm not sure how the shaders should look like. That's my only issue right now. Maybe I have it in here. They probably have it here. Let's see. Shaders. Wow, they have a lot of shaders here. I'm just trying to find the one that takes... this is vertex shader. What are the different... What do they have? They have a pixel shader. Okay, vertex shader. Okay. Here, in. Yeah. I don't really care about these things, but it's okay. So it's literally just this A position, and then you just do that. So I will just do. So it's vertex. So it is like this vertex, and then I don't need to do. Do I just say vertex like this? Vertex like so. Is this, and then like so, and then I'm gonna change the fragment shader, or I could do this still. Let's see. I will not do this, and I will not give a out, and then I will not take a in, and then we'll just say frag color is, let's just make it red. Oh, what did I do wrong? Okay, something is wrong with the run vertex syntax error unexpected right parent expecting comma semicolon and on 14. Am I doing something wrong? Oh, look at that. What? What am I doing wrong here? What? Well, that's the same error that I had from before, but this one compiles. Oh yeah, I changed everything to red. I was like, why is everything red now? But I changed it to red. But then it should be fine to do this. Right? Now it doesn't complain. Well, that's even worse. Okay. Well, now Can you hear? Yeah, now you can hear me. I had some leftover chips as well, so I took that. Yum. Okay. So. The only thing I could think is that I'm actually not passing these vertices. Or then I'm multiplying it incorrectly. One of those two. We can check first that do I even pass these values by going Q render doc, and we will launch application, load this, launch that. Oh, captured user. What? Okay, it's doing a lot of captures. Stop. Okay. I didn't know about this, but okay. This, I think, has it gotten an update? Oh, shit. Let's close that. Let's move this one to over here so we can watch it in full. I want to see... because it should do here. Begin command, end command. Where do we do the draw index? But I want to see where do we... where is... shouldn't... here, bind vertex buffer. Buffer. Okay, here. Huh. Shouldn't I be able to see the data that it actually passed? Unless it didn't pass any data, well then I wouldn't be able to see any data. Well then I would see it didn't pass any data. Huh. Sorry for enjoying some chips. I got hungry. I should actually eat some food. It's late. I don't know. It's almost done. But I might have to see a bit closer, like does this memcopy even work? Because Pig says he needs some chips, you're gonna make some. Damn, that's crazy. I got them on sale. That's how poor I am. I don't eat chips unless they're on sale. Ooh, you donated blood. Nice. Yeah. You need something to get that. What's it? Wait. No, blood pressure up. Not pleasure. Pleasure. Blood pressure. Blood levels. What are they called? Like blood sugar?
Blood sugar levels? What are you, diabetic?
No, what? Gondar donated blood.
He's gonna die of diabetes.
Like, the information seems to be correct here. Apart, it seems to... They got the index count correctly. But the vertices... Those I don't see. So I assume that actually I'm doing something very wrong when it comes here to mapping the shit over. Let's actually check. We can do a... Here. This is my way of debugging. Very nice. We'll return an error saying just cool exit. Because we do cool stuff, right? And then we will do a... Just before we exit, do an std debug print. And we're gonna call it vertex len. And then I'm just gonna say this, and let's see, buffer create info that size. Just to see that, first of all, that this one got calculated correctly. Why is it still running this shit? Did I not tell you to kill yourself? What the fuck? Why is it still running?
Yo!
Please kill yourself.
Ah, there you go.
Why? Won't you die? Why? Okay, I'm gonna try a different one. I'm gonna do a kill all -9 Wallenstein VR. No process found. Wallenstein VR. That should be. Well, this terminal will die apparently. So yes. Okay. Sig build run. Shit. Cool exit. So just before the cool exit, I should have gotten a print. Nah, I just got the cool exit. Wow. What? Maybe I didn't put some new lines here. For real?
For real, man.
Oh my god. Let's do a log error instead. Let's see if that's more okay. I don't seem to be getting. Oh wait, error is ignored. Ah. It's not even. Maybe I should read the error messages, you know. That would be a great start. Okay, let's see. It says 128. I think that is correct because we got 6 of these. And then you multiply that by... Hold the fuck on. That cannot be right. Oh wait, 8 of these, right. What the fuck? Can you please be nice? Like so. Okay, Google calculator. There should be a calculator. What? Here, okay. Because if we got 8 and then we got 4 of these per. Oh no, it just does it by 32, right? Not even that. How does it? Where does it get that size from? That's only. That's nothing compared to as close as what we need. Wait. Let me think. Trade this. We say the len. Oh no, it takes the size of this thing. Yes. And the size of one of these is, assuming, okay, I need to check this because I'm gonna say vertices, and that is gonna be the actual len that we pass in. Len, and then we're gonna do one that is just, oops, size of struct, size, or what did I call it? Type size. So vertices was 8, size of struct, that's not right, that's way too small. Because size of struct, it contains F32s. Or is it enough? It's like, because it's 1, 2, 3, 4, 4 times 4. Wait. Shouldn't say it in bytes. Am I stupid? Because that's now in integers. I think it's too small. What is size of this? Why am I asking AI? That's the completely wrong thing, but I want to just check. 16 is 4 bytes. Yeah, based on the code snippet, 4 32-bit floating point. Ah, yeah, I'm stupid. Yeah, it's 4 bytes. So yeah, you have 4 of those multiplied by 4, so you get 16 bytes. Okay, no, then it makes sense. So you have a struct that is 16 bytes. Is it actually that small? And then we have 8 of them. So it becomes 128. So that's the len is correct. Definitely. Now, my other concern then is, I'm trying to make a shooting system for my game, and I was wondering why my bullets aren't spawning. Turns out they spawn over 100 million pixels from the window. Yep. That's a classic. Okay, so at least we get the size there correctly then. Did we get the data? Just gonna do this. Oops, this one I will still keep as any, and I will call it just data. And then I will just say literally data. Let's see what it actually does, because it's a pointer, but I don't know what it will do. Yes, data is any opaque. Maybe if I change it to the source bytes. Can I say it to be, let's see. No, that did it not like. Could I print byte by byte? Just check, or not byte, character by character. That I could do. For 0 ... source slice that len capture I. Then we will take this. Then we'll put I over here, then we'll take source bytes I, and this will literally just be a C. That is not correct. If I do it to a U8, why would it become? Actually, not. Let's do a integer as well here. 0063. Oh yeah, float. Right, it's right. Fuck. Yeah, because it. But still, it's not enough. That should not be enough. Why is it only going through 8 times? If I take this, cast it to this, and I take that. It should be larger than 8. Because we have the data source len in bytes, right? And then I say source size dot len, and it says 8. That should not be the case. And if I do the bytes instead, let's see, dot len. Oh, there's no such thing as len in that one. What the fuck? How does this work then? Because this cannot be 8. That's too little. It needs to have way more information in it. It's like it needs to be 128, not 8. Why is it only 8? It's so wrong. Why is it 8? Pointer cast. I have freeze first. I'm not. What is FRYSS? I've never heard of that. Let's see. can you not just... Can I try this out for a moment? The vertex that is that you're using len, the number of vertices, to define the size of your memory. Your defined source and destination slices. Len type size, the size of vert. Your code creates slice with len of 8, which is 8, which slice that's only 8 bytes long. Okay. So it's just because... But where does it take this len from? How does it know which of these is associated with? Because it takes 8. Lucas, what's today doing? I'm gonna get a 3-dimensional object, cube, if you may say so. Destination slice, but I don't know what is this len. What is this len? Because if it's taken from here, well, that's a pointer. And if it's taken from here, well, that's another... what the fuck that is. Okay, but let's see how broken can this get. So now it says 128. Okay, so I guess let's remove that. Okay, now it's more like it. I think I have something. I don't think that's how a cube is supposed to look like. I'm not sure. What? Maybe okay, there's many things that could be wrong now. This is... Yeah, I think that is wrong. Maybe the +4 was too much. I mean, it's almost a cube, you know? It's like... I think just some vertices are a bit wrong. Ugh. If you squint your eyes, then it looks alright. Thanks. It works nicely. Nicely what you want. Yes. Okay, well then, I know this should be alright. We can remove all of this. I still want to... Let's see. Just, how do I quit it? Stop it. Is there a stop button somewhere? I don't know how to stop it. To print capture. Why is it taking so many captures? How to exit render doc. Shortcut. There has to be a shortcut to just exit, right? Alt F4. Okay, well, I don't think that. Can it just like die? No. Let's just exit. Yes. No. Fuck. Shit. Exit. No to all. It's still running. Oh, for heaven's sake. Okay, I could have done that. Why is it taking so many like snapshots? I don't need that many. But yeah, let's check this out. I still don't see the information. What? Talk you about the good task manager. Oh, I forgot. You on Linux? Yeah. I don't have a task manager. Oh. This is wrong. What the fuck? What is happening to my vertices? I mean, at least it got all 8 of them. But what the fuck? Why? The data is completely fucked. What happened to the data? This is some garbage bullshit. Like, this is just wrong. 16 less than total data fetch 32. Oh, look at that. We got a beautiful comment here. Let's see. Why would it say stride? Why would it I don't get it. Why would it say that? Why do we create the pipeline, create pipeline, graphics command pool, create pipeline. Stride offset is this, which is 16, but is it I'm gonna try to do something crazy, and then I mean, why do I say size? Sure. Let's just do run. Okay. It's still a bit weird. I don't know if it's better though. Good heaven, I am going to play Boys with Rainbow Six Siege. Nice. What the Risk OS operating system? Do I really need pipeline to render something involved? Yes, you have to. That's the whole idea. That's basically okay. The swap chain is also a big piece of it, but like 80% of the code that you basically write to set up something in this Vulkan is just for the pipeline. Everything will bind to the pipeline, and then you will use the swap chain for the pipeline. So like 80% of the stuff that's how I feel. Like I think it's like that because everything like you create the descriptors pools, you do the vertex, you do the shaders, you bind them, scissor restores, like there's like everything is happening here in the graphics pipeline, and yeah, like that's the majority of it. Mm. But now I'm curious to know why would it want a size of why would it want a F32 here? Am I actually that's like what? Let me check quickly. What does it say if you run now with debug? Can I turn off the stupid launch application? Like I don't want it to automatically capture. I want to do the capturing myself. I don't want to have like a lot of these. That doesn't make any sense. Why does debug delay allow vsync allow full window frame? How do I don't know. In render doc, how do I disable auto capture? To render even that damn triangle, need to that pipeline. Yes, you need. Yes, I did hit the keyboard. I still want to try that. You need a whole pipeline just for a triangle. Even if you wrote the whole like I did, I wrote the triangle vertices inside of the shader. You still need to write the pipeline. In order there is a feature for continuous automatic frame capture. You see no. What? But for me it captures every frame. Bruh, I think it's Gemini is lying. Disable auto frame capture. But I swear to God, I'm not pressing F12 that fast. I'm not even pressing it, and it's still like you can see it goes here. Capture. Here's a define capture. Now I did a. Oh wait, I don't know what the fuck. Maybe I don't. What is a user defined capture then? Anyways. This one I did myself. I don't know what the difference could be, but yeah. Okay, let's check out the bind index buffer here. Buffer. It's not quite our. What? Oh no. Vertex here. Vertex tried 4 less than total data fetched 32. What the actual arc64? Yeah. Vertex tried 4 less than total data fetched. Vertex tried 4 less than total data fetched 32. Okay, maybe it's just the calculation is completely dog shit. And I'm supposed to actually do like this. I don't know, I think that looks as awful as it did before. Let's launch it again. Doesn't really matter which one I open. Well, this matters actually. Fuck. What the fuck? Okay, I did something very wrong apparently now. Oh yeah, bruh. I pressed hold then, that's why. There. Yeah, now I can see it. Vertex 16 less than total. Okay. What am I doing wrong? I need... Yeah, I don't know. Let's see. Certify. It's not controlled by a setting in the... This happens because the application or debug has integrated RenderDoc in application required. It's telling RenderDoc to start and stop captures continuously. Here's the breakdown. Yeah, but so... I think... So I can probably not even change it, I'm just stuck with it. Fuck! I don't like these captures. Okay, here, let's see, because I want to now figure out what the fuck is this. Stride is the byte stride between consequent element within the buffer. So it should be size of the struct then, but for some reason size of CVK, no, what, C XR vec for F. It's supposed to be this then, because that will return 16, right? And then it's per vertex rate, right? Oh, for heaven's sake. Just give me the book. There it is. Okay, let's see. Here. Offset. It's a byte offset of this attribute related to the start of an element in the vertex input binding. This all should be correct. But when I run this, then it's just completely dog water. Like, that ain't good. And then, oops. If I kill that and I go back in here, now we go back to not all. Oh shit, did I even read the right one? Oh my god. Bruh, why do you keep them? Just kill them all. Save this capture. No. Yeah, that's that's just so wrong. Why? Why? I mean, something is right, but most of it is wrong. What the fuck? Whoa. 16 less than total data fetch 32. 16 less than total data fetch 32. So that means it was 16, but fetch 32. How did it fetch 32? 1 should not be that big. It should be 16. Because it's 4, 4, 8, 4, 8, 12, 16. How did it fetch 32? I think that is wrong. 32. Not my stride. My stride is correct. But this is also correct because that's 4, 4, 4, 4. 4. Create buffer. Size. Soon looks will be able to render Super Mario 64. Also, Gemini gave your approximate location based on IP. What? When? Yeah. Here? Oh shit, look at that. Well, that's sure. Then Gemini out here leaking my location.
Damn.
Damn. Very bad approximation though, but it's not too far off. But even though, wait, I'm trying to think this through. Why is it even saying that? I mean, obviously, yeah, my data should not be this. This is so wrong. But I don't understand how it even gets to that, like, because I'm... Can I change the view of this? No. But it's export to bytes. No. Let me quickly see. What? Oh, bruh. Error that typically occurs when the stride value specified for the vertex attribute is smaller than the total data size that is being fetched for each vertex. This measure can lead to incorrect interpretation of vertex data by the graphics pipeline, resulting in render issue or errors. Yeah, okay. Same Vulkan.
Damn, I'm gonna have a nap. I'm gonna catch you later.
All right, good luck with your nap.
Damn, you get 5 free Gemini, like the pro thing.
You do?
Yeah, you go where it says 2.5 flash, go to the top model, and you get like 5 a day, and then it'll go back to the flash.
Ah.
So you go ahead and you ask it.
Yeah. Let's see. Maybe I would. No, I'll just ask if I actually get to a point where it's being stupid. It's not stupid yet.
Also, when you're saying I'm using Vulkan, make sure you use like I'm using Vulkan like development 5.7 whatever it is.
A version. Yeah, I guess that could be.
Yeah, like put the because it's you gotta remember it's the input output. Like it's just gonna like look up the first Vulkan shit it finds.
Yeah, but it's. Yeah. It's usually like based on already the error messages you get. It already kind of explicit what version it is problematic with.
Maybe.
Most of the time.
Maybe.
But yeah.
I know it's I'm napping.
Alright.
Bye.
See ya. Bye bye. The error messages word 16 is less than the Vulkan indicates a mismatch between how you told the GPU to interpret your vertex data and the actual size that the data trying to read. Here's the breakdown of the problem and likely solution based on the code snippet you provided. Vertex try the size of each in bytes of single vertex in your buffer. That should be that. It tells the GPU how many bytes to skip to get from one vertex to the data to the next. Total data fetch. This is the total size of the attributes for a single vertex that your shader is trying to read. Where do I say the total shit? I don't know. Code stride. You're setting the stride to structure. The total data fetch suggests that your vertex shader is trying to read more than just. Yeah, that's weird. It shouldn't do that. Multiple attributes in vertex. The most common reason for this error is that your vertex buffer contains more than just one attribute, e.g. the both position and color. No, it doesn't. But you're only telling Vulkan about the size one of them. The problem your vertex data might be. Oh, wait. 16. Nope. Nope. Where can Vulkan this crazy idea be 32 bytes? Because it is not. The fuck? I have a question. The Vulkan gets the crazy idea from input attribute description. Well, that's funny because I'm telling it that it's not. With the stride of 16, only half of the 32. Then where the 32 comes from. Between buffer. Binding to index 0, yes. Stride the total. How Vulkan total doesn't care about you put in the stride field. Looks like all. But I don't have a second. Why would I do that? That doesn't make any fucking sense. And I also just. I don't get it. Why would it assume that? Why does it assume? This makes sense. Your stride greater than or equal. Supposed to be 16, not 32. That is only bytes. And I will pass in the shader, so we'll understand that that's the input that I'm taking. For its source problem isn't that with this tried byte, you are correct that your data is only 16. The problem is with your shader input. This tells that Vulkan pipe on your shader respect a vec for 16 bytes. Yes, this I just tried, yes. The hidden attribute. The validation is finding a second unmentioned vertex attribute that is causing the total phase to be 32. Give your code this almost certain due to the following comment route. But I don't use it. Oh, it's not a problem. It's not a hint. Oh my god. Or do I tell it somewhere? But I don't wanna... I'm not supposed to use that. Well, that's funny. I don't have this one. Or do I? Wait, fragment. No, I don't. It's the vertex, 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 vertex. That's a problem is most solve the most common cause. If you triple check that you are not creating a you only have one and it's correct. Even if you don't create second attribute description, you might be telling Vulkan that there are two of them. No. No. Previous pipe migration failed. Struct has previous used for different pipe, perhaps one with two attributes. You might have still creating multiple pipelines. The first pipeline correct. Use two. No, I'm not doing that. But could have been. How to check? Huh? Missing data debugger shader. Let's see. Data from the different shader or different parts of your program. But then nothing should work. Okay, but we can still check, remove that. So in the sig out, here I usually have the shaders, so I will just delete them. Wait, that's not how, fuck. It's trash, and if I launch, and now it's still problematic. Well, that's a lot more stable for some funny reason. can it do that? There's one thing that I'm considering that could be doing this, and that's these normals. So if I just don't use them, but I don't think it should still. Because I have been ignoring them this whole time anyways, so they should not be an issue. Right? And then here I just say 1. Oh my god, and then I do this. Instance count, index command buffer, binding count 1, offset. Oh, but that should be, that shouldn't be a, well, I mean we can try, but I don't think that should make anything better. But I will see. Because that, if I understood correctly, I should be using what I use for the index size, and the index size I used 32. So that one should be fine like that. But let's see. Draw index, vertex. Yeah, no. Vertex try at 16 less than total at 32. Index type. Index type is the PK index type value specify the size of the indices. Yeah, the size of the indices, not how big. Offset starting the offset is a byte for the buffer used in index buffer address location. No, nothing should work, but let's see. Yeah. Just wanted to confirm my idea about that. But I have to somewhere be telling it that it's should be expecting a bit more, right? Oh, wait on. Wait, hold on a minute. Frame buffer. Have I not? Oh my god. No, that is correct. Right? This is for the descriptors, they're not relevant, right? But there is one thing that could be relevant. Descriptor pool here. Max set. No. Descriptor pool. Bit. But this is just for the no. I'm tripping. Shader module. Okay, let's see. Shader. One type flag binding type but that is where we create the vertex shader. So this one should be fine. I don't get it. What am I doing so wrong? Must be doing something like super wrong. What could that be? I'm just gonna try some weird values right now. Wait, what? Huh. Huh. No way that was. So I must have misunderstood, maybe. Well, that looks a lot more like it. So I must have misunderstood. I thought... Right, because I don't have an offset. Because I only have one. Yeah, that tells the offset where the input is supposed to start, and that's why if it says 16. Damn, I'm stupid. Oh no, how could I? Oh my god. How could I mess that up? For real. I'm a bit disappointed in myself, to be honest. That's just silly. That's yeah. No fucking way. Well, I guess now I can be a lot more sure that, yeah, this... But I didn't see, like... In here... Wait, there it is. I'm trying to find this thing. Fuck. Yeah, I'm not gonna find it here. Which one am I? Wait, it's... Here. So they did this, and then... Oh! Stride. And how did they have pose and color, but because they have a function to calculate this thing, and that's why they just do this. But I don't need that because I don't have. Oh my god. Or function. I think that's a macro. I'm not sure. Is it a function or macro? I don't know. But yeah, and it makes sense that. Damn, I'm stupid. How could I miss that? How could I? Well, now there's a cube. Pretty damn freaking cool. Whew. Let's give it some. I need to go take a pee break. Beer pee. All right, crazy. Let's see. We can now start doing some funny stuff, like I would like to make this. Let's see, we don't need that actually anymore. But I would like to do a separate we can do this. Take this. Can you not just do sin? And then just it's a vec 3 in this. Okay. Vec 3. Right, doesn't know what. Damn. No, that should be fine. Can I not just do that? Ah, and oops. Here, fragment. We'll take this and just say color. Well, that's that was a bit smaller value than I had hoped for. It's fine. Kill that. Cos GL, and let's do tan GL vertex index. Yay! Look at that cube. I wonder why it's so black still in some corners, but might have something wrong, but it's okay. It's we're getting closer to getting a cube. I will actually do a. Ooh, let's go. I'll do a peak kill real quick, and then I will just go over to here. I will stop this, yes.
I'll unplug my headset.
My whole VR system.